Hello, Japanese engineers. How are you? I hope everyone is safe from the coronavirus so that we meet each other face to face soon. Today, I'd like to talk about the new development item of Daful. DriveTrain Toolkit has been successfully used for NVH analysis on time domain. We extended the DriveTrain toolkit for the robots. I will tell what they are. Daful NVH analysis has been integrated with many other related software so that not only the time domain analysis but also other NVH design requirements can be satisfied by using other software. So, including all the design modification of NVH analysis can be carried out with the many other software together with Daful. I will tell what they are. Solving speed has been always an important issue to do more design iterations. To satisfy the speed requirements, we developed Hpc Solver. This solver is based on the preconditioned conjugate gradient method, so the linear solution process carried out iteratively so that it has a very good scalability on massively parallel computers. I'd like to talk about the scope of Daful. Daful covers multi-flexible body dynamics, strength and fatigue analysis, vibration, linear and nonlinear, NVH time domain analysis. Also, we have NVH linear eigenvalue analysis. Heat transfer and design of experimental design study can be also carried out inside the Daful. For the application of Daful, Daful covers heavy industry and automotive industry and also electromagnetic field.
Now I'd like to talk about the new development items of DriveTrain. The first one is the Cycloidal reducer modeler. Cycloidal reducer is well known as RV reducer. Cycloidal reducer modeler consists of pin-type cycloid, housing, crankshaft, planetary gear set, and output shaft. And this cycloidal reducer can be used in the base mount of a robot arm. This cycloidal reducer can be created by using the dialog box shown here, and this modeler automatically creates and assembles all the components. After we do transient dynamic analysis using Daful, hysteresis, transmission error, and efficiency curves are calculated from Daful, and it can be directly used to evaluate a robot performance. Next one is the strain wave gear modeler. Strain wave gear is well known as harmonic drive. Strain wave gear modeler can be used to model strain wave gear used in the joint of a robot arm. This strain wave gear transmits power with high accuracy and high gear reduction ratio. It consists of a circular spline, flex spline, wave generator, and flex ball bearing. Flex spline deforms to produce the required motion of a strain wave gear, and by using this analysis, the tooth contact pattern of the flex spline can be obtained from the solver. And this tooth contact pattern is very important in the design for flex spline, so that information can be produced by using Daful. Also, hysteresis, transmission error, and efficiency curves are calculated from Daful and reported with the format to measure the gear performance.
Now, I'd like to talk about DriveTrain Toolkit coupling with electromagnetic analysis. Tuple has been successfully used to predict gear white noise, rattle noise, and waterfall graph can be created by FFT analysis of the time domain result obtained from the Tuple. So here is some example of waterfall graph obtained for gear white noise, and this vertical line represents the gear net noise in the frequency domain. Now sometimes we have gear driven by the motor. So motor dynamics is very important to include to predict the system performance. Therefore, the motor effect has to be included in the analysis. Here is some waterfall graph obtained from combined analysis of motor and gear together. And if you change bearing position, now sometimes we wanted to know what kind of result can be obtained from the design modification. Here is some example. As you can see, the waterfall graph is changed significantly when we change some of the bearing design position. So now we realize that it is very important to include electromagnetic force effect obtained from the motor. Now, ANSYS Maxwell calculates electromagnetic force which is transferred to the Tuple for the time domain analysis. ANSYS Maxwell analysis carried out independently, so we produce a table of the torque and force at each different angle and rotational speed. Now, when we do Tuple time domain transient analysis, the angle and speed would be very different from what we obtained from ANSYS Maxwell. So we have to interpolate by the angle or rotational speed to produce very exact force and torque obtained from the motor produced by ANSYS Maxwell. And also the mesh of the ANSYS Maxwell and mesh of the Tuple are generally different. So we need a mapping algorithm which maps the table obtained from ANSYS Maxwell and to be used in the Tuple transient time domain analysis. Here is the how we include electromagnetic force. We have solved one electric vehicle speed reduction system noise analysis after we developed electromagnetic force. In this system, three parts consist of a whole system. The first one is drivetrain system. Drivetrain system consists of bearing, gear, and shaft. Now in the shaft, we can use the flexibility. We can use the EasyFlex to predict flexibility of the shaft. And motor consists of rotor and stator. Also, rotor and stator must be modeled as a flexible body, so we can use EasyFlex module of the Tuple. And then housing also, it must be modeled as a flexible body, so housing also EasyFlex can be used to model housing. So using the NVH capability of the Tuple, including electromagnetic force, we can do evaluation of short time Fourier transform, order tracking, and evaluation of tooth contact pressure and mode contribution. Here is some example of the EV speed reduction system. We applied the Maxwell analysis and DAFUL analysis has been carried out to measure NVH performance of this gear system. After we do time domain analysis, acceleration of one point has been extracted. From this acceleration information, we carried out FFT of this acceleration information to obtain short time Fourier transform. Now, as you can see, there is two waterfall graph. One is with the electromagnetic force. The other one is without electromagnetic force. If you compare these two waterfall graphs, you can see the drivetrain frequency can be obtained without electromagnetic force, but with the electromagnetic force, we can also include motor frequency as well as the drivetrain frequency. And also from this waterfall graph, we can extract order tracking information of a specific frequency. And also from the exact contact algorithm, tooth contact pressure with the electromagnetic force can be obtained so that we can change our design to have a uniform tooth contact pressure. Now I'd like to talk about DAFUL workflow for complete NVH analysis. DAFUL has been used successfully to predict NVH result from the time domain. However, it is not sufficient. In order to complete the whole NVH analysis and also design modification, additional softwares are required. Here are some integrated software with DAFUL. The first one is the Space Claim. ANSYS Space Claim is a CAD design software. So when we need to modify the CAD geometry, we can use ANSYS Space Claim, and the result of the ANSYS Space Claim CAD file can be directly imported into the DAFUL and can be used as a design objects. And second software integrated is a KISS software. KISSsoft is a gear tooth design program. Gear tooth design can be carried out inside the KISSsoft, and the results of the final gear tooth can be imported into the DAFUL and can be used for the gear profile. And also ANSYS Maxwell is tightly integrated with DAFUL so that electromagnetic force can be obtained from ANSYS Maxwell analysis. And motor design can be changed from the ANSYS Maxwell, and the electromagnetic force automatically generated and imported inside of the DAFUL. After DAFUL produces surface velocity, this time domain result immediately converted to frequency domain results and then imported into the ANSYS acoustic software to find out the radiation of the sound pressure. And this pressure can be generated by ANSYS VRX experience sound tool, so that these tools are tightly integrated with the DAFUL so that user can use just like one software. When we do ANSYS acoustic analysis, first of all, DAFUL produce time domain result and velocity of the surface of a CAD profile are calculated. And then this time domain result converted into frequency domain result by FFT transformation, and this data converted into the mesh of the ANSYS acoustic software, and then the radiation sound pressure are calculated from ANSYS acoustic software. Finally, I'd like to talk about high performance computing, HPC computing, with massively parallel processing computers. Our new solver is based on preconditioned conjugate gradient method. Since more than 80% of computation time of time domain analysis is spent in linear solver, it is very important to obtain good scalability of the linear solver for additional processors. So not only the speed scalability, but also the large size problem can be solved by dividing the memory usage into many parallel computers. Here are some performance results. Generally, dynamics problem is relatively smaller than structural or eigenvalue problem because we have to do many iterations. So it is important to have good scalability for large scale problem, but also smaller scale problem. So here are some results. As you can see, Daful produce good scalability for small number of processors as well as large number of processors. I'd like to talk about the future plan. Beginning of next year, beginning of 2021, we will release a 1D vehicle simulator, new Maxwell interface, orthotropic material, and beam contact. And also we'll release new post-processor which is much powerful than existing post-processor. And also tooth modification capability inside the Daful will be added, and motor and automotive drivetrain modeler will be included. And also the DEM software Rocky will be integrated with Daful, and also master interface will be included at the beginning of 2022. Thanks for your attention.